Welcome to E-Pathashala Architecture lecture series for MArch students. In the previous modules, we have seen when it comes to GRIHA, how site planning and energy is an important criteria. In this series, we will see how energy can be used. Here we will see renewable energy source in order to design green buildings. Renewable energy utilization. So, this criteria talks about meeting energy requirements for a minimum of 10% of the internal lighting load for general lighting or its equivalent from renewable energy sources. So, it means basically we must not depend on the energy grid completely for all our requirement to run the building. A small part of it at least for the internal load must be got from renewable energy sources. Renewable energy sources can be solar energy, wind energy, biomass, fuel cells, etc. Energy requirements will be calculated based on assumptions which will be subject to verification during appraisals. Using renewable energy sources in buildings to reduce the use of fossil fuel based energy sources is the main aim of this criteria. How can we do this? We can use the easiest way in a hot country is we can use solar energy which has solar array. Energy is captured and stored in batteries on inverters and it is directed to various uses. A part of the internal lighting load can be got from this inverter, or some of the computers can also be made to run using this solar grid. Renewable energy based hot water system is criteria 19. We must ensure that a minimum 50% of the annual energy requirement for heating water, that is all applications which require hot water in canteens or for washing and bathrooms or toilet except for space heating, must be supplied from renewable energy sources. In some of the cities it is mandatory that in commercial buildings or hospitals the entire requirement for hot water must come only from renewable energy sources. Again, it depends on the place or the city. Even otherwise, GRIHA prescribes that at least 50% of the annual energy requirement for heating water must come from renewable energy sources only and must not be dependent completely on the grid. Next, we will see recycle, recharge and reuse of water. The objective of this is to promote the recycle and reuse of water. Criteria 20 talks of wastewater treatment. So, provide facility for the treatment of wastewater generated in the building so as to have safe disposal and use of byproducts. So, what are the various water that we are talking of? There are these various types. One is grey water, second is brown water, third is black water. Grey water is nothing but the water that comes from the kitchen sink, wash basin. Brown water is nothing but the storm water runoff, and black water is the water that is got from the sewage, from the toilets, from the closets. Here we are looking at two systems to treat black water. In this system, the black water goes through a series of treatment until the water is treated and let off into the nearest water source. But there is another much better way of treating the water. It is called as the root zone treatment here. What happens is there is a large pond here very close to the house and the sewage is led directly into it. Automatically the sewage gets treated. How it happens we will see later. This is the root zone treatment. Water, black water from the toilet is let inside along with the sewage. Here this pond or root zone treatment pond has a lot of important or very specific plants on it. Now, this plant has the capacity to eat nitrogen very fast. They require a lot of nitrogen. So, what they do is they break down the sewage very quickly into finer particles. The sludge remains down, called as the muck layer, remains down, and the outside water can be taken off and then it can be watered. Again, the rule is that the water must never be used as sprinkler, but only be underground or subterranean. This muck can be taken out, dried, and can be used as manure and compost. Also, another important thing to tell is there will be no foul smell coming out of root zone treatment if it is done properly. Criteria 21 talks about water recycle and reuse, including rainwater. Utilize the wastewater treated on site and rainwater for various applications, including groundwater recharge, where potable municipal water is normally used to reduce the load on both the municipal supply as well as sewerage system and to improve the groundwater level. So, recycling and reusing of grey water or black water aids in reduction of municipal water supply as well as recharging groundwater. Here we can see how rainwater is utilized. Rainwater is through various catchment means. Rainwater is collected and it is taken either through a pipe to a particular place for recharge, or it is collected in a large tank where it gets treated. This treated water is stored and it can be used for various purposes. Waste management. The objective is to minimize waste generation, streamline waste segregation, storage and disposal of waste, and promote resource recovery from waste. We will be talking about two kinds of waste. One is solid waste, another is liquid waste. So, reduction in waste during construction is also another thing. Ensure maximum resource recovery and safe disposal of waste generated during construction and reduce the burden on landfill, because ultimately any waste which goes to the landfill is going to seep into and destroy the water resource below. Efficient waste segregation. Use different colored bins for collecting different categories of waste from the building to promote the segregation of waste for efficient resource recovery. Here we are talking mainly about domestic waste and commercial waste. We are not talking very specifically about hospital waste or industrial waste, both of which are toxic. Industrial waste is toxic, whereas hospital waste is biomedical waste, which is infectious. Here we are talking about things like residential waste or commercial waste, which comprises mainly of organic and inorganic things. So, organic things that comes as waste include vegetable peels or any waste food. Inorganic waste comprises of paper, plastic, leather, clothes, metals, etc. What must be done is, from this picture you can see that there are two kinds of bin. One is the red bin, another is the green bin. While collecting itself, from the source itself, waste is segregated into organic and inorganic waste. The organic waste goes to, in this right hand corner picture you can see a series of tanks. These tanks are the various stages or process of breaking down the organic waste into compost. It can be done in the composting yard through vermicomposting. These are the various types of compost, vermicompost that is got from the organic waste. The other inorganic waste can be separated like this, as shown in this figure. Like each bin can comprise for paper or plastic or metal, leather, etc. and this can go for recycling. Storage and disposal of waste. Allocate separate space for the collected waste before transferring it to the recycling or disposal stations to prevent the mixing up of segregated waste before processing or disposal. Which means in your own site you need to have very clear spaces for storing the segregated waste so that they do not get mixed up, which means a big bunch which goes for recycling in a steel plant must not get mixed up with bottles, glass bottles. Resource recovery from waste. Make arrangements for recycling of waste through local dealers to maximize the recovery of resources from the recyclable and biodegradable waste and to reduce the burden on landfills. A lot of this has to do with how a designer looks at a project and also at the building materials. Designers are capable of designing parts of buildings or furnitures or some elements inside the building by using what is considered as waste by the outside world. Here you can see that a bench park in a bench is designed with recycled content from elsewhere. It does not look anywhere like a waste, but yet it has saved the landfill from unnecessary burden. Next is health and well-being during post-construction occupation. The objective of this criteria is to ensure healthy indoor air quality, water quality and noise levels and reduce the global warming potential. What are the ways in which we can ensure that the indoors or the indoor air quality is good? This can be done with criteria 26, which talks of use of low VOC, volatile organic compounds, paints, adhesives, sealants. Building materials such as paints, sealants and adhesives form important finishes to the exterior and interior surfaces, but they are potential contributors to the poor indoor air quality and can have a bearing on an occupant's health. So, we need to ensure that the paints that we use are very low in VOC. One very easy way of finding out if a paint or an adhesive inside is of low VOC is low VOC compounds will not give out a very pungent strong smell, unlike the ones with high VOC. Use of low VOC compounds, especially formaldehyde, urea formaldehyde and urethanes and other chemical substance contained within the building materials, it can be injurious to health and can also be odorous. This measure aims to select materials with low to zero quantities of such chemicals so as to minimize the source of emission. In selecting low VOC materials, a practical thumb rule is to choose water-based products with low odor. Criterion 27 talks about minimizing ozone depleting substances. Employ insulation that is ODP, ozone depleting potential free, HCFC, hydrochlorofluorocarbon and CFC, chlorofluorocarbon free, HVAC and refrigeration equipments and halon free fire suppression and fire extinguishing systems to eliminate or control the release of ozone depleting substances into the atmosphere. Toxic materials source reduction. This can be done. One of the examples here I am showing is reduced mercury in light bulbs. So, we can find alternate ways of lighting the building in such a way that we do not use toxic or heavy metals in the bulbs. Criterion 28 talks of ensuring water quality. We need to ensure groundwater and municipal water to meet the water quality norms as prescribed by the Indian standards for various applications. Indian standards for drinking is IS 10500-1991, irrigation applications IS 11624-1986. In case the water quality cannot be ensured, provide necessary treatment of raw water for achieving the desired concentration for various applications. Criterion 29 talks of acceptable outdoor and indoor noise levels. We need to ensure that outdoor noise level conforms to the Central Pollution Control Board, Environmental Standards Noise, Ambient Standards, and indoor noise level conforms to the NBCC, National Building Code of India 2005, Bureau of Indian Standards 2005A, Part 8 Building Services, Section 4 Acoustics, sound insulation and noise control. It is an important criteria for two reasons, especially if the building also demands acoustical treatment. If it is a building which has an auditorium, by all standards we need to ensure that it follows all norms of noise reduction from the inside to the outside and from the outside to the inside. Even otherwise, in regular buildings, noise can become a pollution if it exceeds certain levels. In green buildings, we are trying or aiming to reduce all kinds of pollution, including noise pollution. Hence, it becomes mandatory that a designer or an architect looks at indoors and outdoor noise levels too. Criterion 30 talks of tobacco and smoke control. Zero exposure to tobacco smoke for non-smokers and exclusive ventilation for smoking rooms is a must. Therefore, in all public buildings, if it is necessary, one must provide separate smoking rooms or smoking corridors, which means people who do not want to by choice get into smoking or inhale the toxic gases from tobacco, they must be shielded or protected. Criterion 31 talks of providing the minimum level of accessibility for persons with disabilities. Now, who are people who are disabled or physically challenged? People who are orthopedically challenged, which means people who have their limbs affected, people who cannot see clearly, whose eyesight are affected, people who cannot hear clearly, also very elderly people, also pregnant ladies or women, they all come into being physically challenged at some point of their life or the other. To ensure accessibility and usability of the building and its facilities by employees, visitors and clients with disabilities, the entire building must necessarily be barrier free. How can this be done? When it comes to buildings, there are various ways, but when it comes to campuses, these are the following ways. If you look at this person, you can see that there is a clear pathway for the person to walk who is physically challenged, who has a particularly sensitive stick which he can tap, and you can see that the pathway is bordered with a particular material. Now, when a person who is physically or who cannot see, a blind person, when he taps on this particular material or when he puts his feet on it, he can sense the change in texture, and therefore he would know he is not supposed to walk onto the other side of the path. There are many other materials which have texture, and therefore change of texture seems to warrant that the person needs to fall in line. People who cannot see, when they get into the lift must be such that people who can't see or blind people must be able to operate it. This can be done by having an audio system inside the lift, where the lift is able to talk and tell. Also, for the physically challenged, ramps are mandatory. Any building, any public building in India must be barrier free as per norms. Building operation and maintenance. Validate and maintain green performance or levels and adopt and propagate green practices and concepts. This tries to say that, this criterion tries to say that once you get a particular building gets a GRIHA certification for its greenness, the building or its operation must not forget at that point itself, which means all through the operation of the building's life cycle, it should ensure or maintain greenness in every sphere of its organizing. For this, energy audit and validation happens. Energy audit report must be prepared by approved auditors of the Bureau of Energy Efficiency, Government of India. So, energy audit must happen in the first time as well as throughout the building's lifetime from point to ensure that they do not deviate from being green. Building operation and maintenance as criteria 33. Validate and maintain green performance. adopt and propagate green practices and concepts. Meaning to say, when a building is designed to be green, the building must also produce something green. Green certification given to a building which is going to produce high intensive, energy intensive materials may remain meaningless. Innovation, very important criteria for an architect. 4 innovation points are available under the rating system for adopting criteria which enhance the green intent of a project, and the applicant can apply for the bonus points. Some of the probable points, not restricted to the ones that we will be talking of, could be alternative transportation. So, apart from the checklist of the points that we have already discussed, a designer or an architect is given a freedom to innovate anything that he wants in a building which is going to aid in greening the building further. One of it could be an alternate transport, though there are many other. One can be environmental education, which means the building itself can be a role model or an example of environmental education. Company policy on green supply chain. As I had already said, a building or a company which generates energy intensive product cannot be asking for a green rating system for itself. Life cycle cost analysis. Through the life cycle cost analysis, a designer can always prove that his building is extremely green in the long run. Enhanced accessibility for physically and mentally challenged. Any other criteria proposed by the client. Here are some of the examples where innovation is a key in getting the building some points. One is roof vegetation membrane. What can be done is, we can have the entire roof insulated and have a terrace garden. By doing this, there are a few changes that can happen to the interiors of the building as well as changes to the microclimate. When it comes to the building interiors, the indoors can remain cool. Beyond that, depending on what is grown, if it is vegetables, if it is daily use vegetables, then it can also create a feeling of social community, and therefore, the aspect of social sustainability can also be enhanced. Further, if you look at the thermal imagery of a place which has a lot of green roof, we can see that the entire microclimate of the place has changed. But all these things are innovations included within the realm of the building done by the designer, and these will carry extra marks. So, before I conclude, I would like to summarize what we have seen now. We have seen about waste management. When we look at waste management, there are two aspects we must consider. One is wastewater, another is solid water. Wastewater further comprises of grey water, brown water and black water. Grey water must be reused by collecting properly and then dispersing subterranean without using sprinklers to water lawns as well as vegetable gardening. Storm water, which is also called as brown water, can be done by collecting the storm water that can be treated, and further it can be used for any purpose other than drinking. The third water we talk of is black water. Black water comes from the sewage. It can be treated by two means. The conventional way of doing it is giving it to the sewage treatment plant, and then the water that comes out of it gets into the river. The other way of doing it is the root zone treatment plant. Root zone treatment is nothing but a large pond into which raw sewage is taken, and then with the help of certain plants which are voracious eaters of nitrogen, the entire sewage is broken down. The water that comes out of it can be used for watering the plants, while the sludge can be used as manure. The next aspect that we saw was solid waste management. We are looking only at domestic solid waste, which comprises of organic and inorganic waste. Organic waste are waste which are biodegradable. They comprise mainly of vegetable peels, waste food. What can be done out of this waste is, it can go either to the compost yard or the vermicompost yard. Both are different techniques of composting organic waste. The inorganic waste can go to a segregation point, and from the segregation point it can go to the recycling point. After this we saw innovation. Innovation is something which an architect can do in every realm, every sphere of his design, right from the way he looks at his site, right from the way the building is designed, right from the materials that he uses. The material can also be something extremely innovative which is not available on a commercial basis. So, when all these aspects are considered, the building can be gone for, it can go for GRIHA validation. If I summarize all the 3 modules under GRIHA we have seen how site planning forms a very important part, how health and care of workers forms an important part. We have seen how energy, end use and embodied energy is very important. We have seen how waste must be segregated and used as an important aspect, and last but not the least, very important is innovation. Hope you have a gist of what GRIHA means to Indian green building scenario. Thank you.